Fresno State Physics Outreach. They're here. I'm sure you can tell by what's out here with us. But first, so we're going to talk to some kids, some students in the program. But first, we're talking lasers and optics. So joining us now from Fresno State's Physics Outreach is Professor Don Williams. All right, so we're talking lasers. We're talking light.
Before we get to lasers, let's start with like the basic light bulb.
Okay.
The basic light bulb is basically running electricity through wires, heating them up, and different kinds of wires that produce different kinds of light.
Correct.
That's basically, but that's all that really is a heat source is what it really is, right? Now they've come up with these things. What kind of bulbs are these?
LED.
Yeah.
It's not hot.
Exactly.
There's
It's a
no
totally
heat.
different process.
Right, okay.
It's a light-emitting diode.
Is it
a totally different system. Yeah, so this is more like light.
Oh, yeah, it's a little hot. Yeah.
It gets pretty hot, exactly. So that's how the light started out.
Okay.
Now, we're showing in our little tree here, we've got all these different colors, right?
Oh, yeah.
And it just depends on what you would burn and what you would heat up. So you could heat up hydrogen gas, you'd get a certain color.
Right.
Neon, you get the neon lights.
You get the neon lights, yes.
You get all those different kinds of colors. So really what it's to do with, it's these electron transitions, so to speak, in between things that make all that different kinds of light. Now you've heard of lasers, right? Now I brought a few little lasers here. You're familiar with these kind of lasers,
like the laser pointer.
Exactly, the classic laser pointer,
like you put in the classroom.
Exactly.
Okay.
Now, what does laser stand for? Light amplification. So it amplifies light.
Oh, it's an acronym?
Yeah, by
I had no idea. Okay.
By stimulated emission of radiation. How cool is that?
I'll never remember that.
Yeah, but you know it is. And it basically bounces stuff back and forth.
Okay.
It gets everything stimulated and shoots out one color.
Right.
Monochromatic. Like this is a green laser. Exactly, a green laser.
Cool.
Exactly. Now, we want to kind of show you a beam a little bit of it.
All right.
Now, you guys know when you generally shine a laser, you don't really see the beam, you see a spot where it hits.
Right.
That's all you're seeing is a spot where it hits. You might see a little bit, does that mean a little bit?
Tiny
bit. We're going to improve that. Let me show you what we've got to do. So that's a tank.
Okay.
So we're going to put some Fresno water in there that probably has a little bit of stuff in it.
A little bit of chlorine in there?
Well, just flat particles that the light can bounce off of so we can kind of see it as a beam. Because otherwise you really don't see it as a beam. Right,
you just hit the spot where it lands.
That's it, you just see that, that's all you see. Even though the beam's there, you know the beam's there, there's no doubt. So I'm going to put a little water here, and then I'm going to put, we'll try just the water by itself, see if we can see the beam. And then we'll try the actual, it's a little bit, but let me show you what we're going to do to amplify that too. We're going to put a little coffee mate in there. All we're going to make is the water a little bit dirtier now. And then we should be able
that is a little bit.
See the beam here in a second, okay?
Oh, okay, I see. I see. You shoot the beam, and I will tell you what my hypothesis is.
Can you see the beam?
Yes, I can, because now the beam has something to land on.
Right.
When we shoot it through this concoction.
Tracking, bouncing off of there, exactly. And there's actually a mirror in the bottom. It's getting kind of a little mucky in there.
Yes.
It bounces off, and you see how light bounces off.
I do.
And comes back at that angle. You know, we could even make a little bit of a mess. And we're allowed to do this because I know I get in trouble.
Our production crew is going to love this. All right.
So I'm going to take the beam here and I'm going to sprinkle a little bit of this right on the beam, and we should be able to see the beam. See the beam?
Okay, you know what that reminds me of? Is when we used to throw cinnamon in the oven. You know where they have the heat elements on the bottom? Yeah, we used to throw cinnamon on it.
There you go. There you go.
See, I was learning science even back then.
Emily, you're a big-time scientist, man. That's what I like about you. Now, let me get this out of the way.
Okay.
And I want to talk a little bit about where lasers come in real handy.
Okay.
Is in fiber optics. Like you guys know telecommunications.
Right.
That made a huge jump.
Right.
Instead of one signal going through a wire, we could put it through plastic, or we could put it through glass fibers. Now, this is a big one. Let me see how that's all bent.
Yeah.
Well, what I'm going to do is I'm going to shoot my laser in this end, and it's going to shine out that end. Take a look at that.
Oh, my gosh. Okay, so this is essentially what, that's what fiber optic.
This is a very large fiber optic.
So when we talk about really high-speed internet, like in other parts of the world, so in like South Korea, they have internet that blows ours away because it's fiber optic.
Fiber is the way. I can show you maybe a little bit in this ring too. If I shine it, let's see if I get it just right. We can sometimes see it going around the edge.
I do.
You see it kind of going around the edge
a little bit,
right
there.
A little bit, all right?
Yeah, okay.
But now I also have a real fiber optic.
Okay, so that's real. So that's super
what
tiny.
Can you see? That's what they really put through wire. That's really a fiber optic, a real live fiber optic inside there, right?
Okay.
So what I'm going to show you, Emily, is you hold that in right there. And see how that's all wound up?
Yeah.
I'm going to shine it in this end.
No
and
way.
And it's going to come out that end, man. I'm serious. It's going to come out that end. All right, let's see if I get it.
Oh my goodness!
Check that out. You guys see that? Can you see that little green light? I'll turn it off, and then I'll turn it on. Check that out. Now you try it. You shoot on your end.
That's wild.
You shoot on your end. Just put it right on the end of it.
Okay, I'll do it.
Right on the end,
I'll do
and
it
let's see if it comes out my end. Got it. See?
Oh my gosh, that's wild.
Can you see that? Oh, behind the cup. Yeah, behind the cup.
Oh my goodness.
Can you see that? So the signal can go anywhere, so you don't have to have anything straight, right?
Right.
The reason is it comes back to this tank we had.
Okay.
The way light bounces up and down.
Yeah.
If you make a fiber, it can bounce up and down all the way down the wire.
Okay, so I never knew really what I was talking about when I said fiber optic, but I told everybody that's what we needed for good internet. All right, you have one more thing you want to show us down there.
Exactly. I want one more thing I want to show you guys.
You have one more thing you want to show us down here. I was
exactly. Exactly. This thing, exactly.
Okay.
There you go. Shine on with your laser on it. So this one, I think you guys can see that black barrier in the middle. You see that black barrier?
Yeah.
And I got a ping pong ball, but when I tilt that, watch the ping pong ball roll through there.
I thought it was solid.
I know, it looks solid. It looks black. I mean, it definitely looks black. Do you agree with that?
Why does that happen?
So you know it isn't really.
Yes.
This is actually Polaroid material. This is a way we block light. Like, you've heard of Polaroid sunglasses?
Yeah.
We're going to do this on a whole other show. I'm going to talk all about that. We're going to talk about Polaroid, because what it does, it takes and cuts the intensity down.
Yeah.
And
blocks
actually
light.
dimensionless in one line. Yeah. And I've turned the Polaroids so it makes it look black there.
That's crazy.
Yeah. If you have sunglasses
so is it
on
the
right
same
now,
technology that we find in the Polaroid camera?
Yes, similar. Well, but that's a little different, but the Polaroid idea, the Polaroid material. Yeah, the Polaroid camera.
Material.
Yeah, the material.
I see.
Like sunglasses.
Right.
Polaroid. If I had my sunglasses, which I don't have them on me right now, you would see
Very
one half of that
interesting.
black. So again, the light does all kinds of things. We learn tons from it,
Yeah.
right? And we teach all kinds of great classes out at Fresno State about light too.
Well, he can come, and Don Williams and his students, they can come teach you all about, they can teach you about fiber optics, physics, all kinds of stuff. We're going to keep them around so we can do more. See, there it is. Look at me. Look at me. It's like science.
See?
Okay, you guys are going to stick around. Everybody else, stay right there, because we have more after we chat with a couple of other people. We'll have them back. Our friends from the Fresno Yosemite Airport, they're here to talk about the aviation job fair. That's next.